So the last quadrilateral that we're going to talk about is a kite. We've talked about parallelograms. Parallelograms have two pairs of parallel sides. Then we've talked about trapezoids. Trapezoids have one pair of parallel sides. And now kites have no pairs of parallel sides. No sides, none of the sides of a kite are parallel to each other. So the properties that a kite does have, one of the properties is that two pairs of consecutive congruent sides. So what that means is that, for instance, consecutive means one right after the other. And so we have these two sides. AD would be congruent to AB. And then we would have CD and CB. So those are the other two consecutive congruent sides. Okay. The other thing is that the diagonals are perpendicular. So this is another shape that has those perpendicular diagonals like a rhombus and a square does. And that comes from those consecutive congruent sides, because a rhombus has consecutive congruent sides too, and that because all of the sides are congruent. Vertex angles, which are those angles that are between those two congruent sides. So angle A is a vertex angle and angle C is a vertex angle. Okay, so that says angle A and angle C are the vertex angles. They are bisected by the diagonals. And so that means that angle A got cut in half and angle C got cut in half. The diagonal connecting the vertex angles bisects the other diagonals. So AC, what that means in this particular picture is that AC bisects DB. So now DB has been cut in half into two equal pieces. And then the non-vertex angles are congruent. The non-vertex angles are D and B, and they are congruent to each other. So I will mark those with three little marks. So those are congruent to each other. Now notice they're not bisected. So this is angle D is congruent to angle B in this picture. So it's not bisected. Those are not bisected. So one gets bisected and one is congruent. Okay, so let's use those properties to set up and solve some problems. So a couple of things when you first look at this. When you don't have a clue as to where to start, the best thing to do is just label anything that you do know. So the first thing that I see when I first start this problem is I know that the diagonals are perpendicular. Once I know that those diagonals are perpendicular, it kind of helps me to start setting things up. Now, notice that a kite is made up of 4 right triangles. So that's going to come in handy. So then what I know is I need to go to the triangle that has the most information, and that is going to be this one right here. Because we have a 90-degree angle, we have 3x plus 5. And so, and then I know this other one. Well, what's this other empty angle? Well, remember that those angles are bisected, so it is also 2x plus 5. So what I know is that those other two angles are complementary angles, so 2x plus 5 and 3x plus 5 have to equal 90 degrees to finish out that right triangle. So 5x plus 10 is equal to 90. So when you solve for x, you get a divided by 5, which is 16. So you get that x is equal to 16. Now we want the rest of the angles. If x is 16, then I can go ahead and start filling everything in. This angle is 32. Well, now if that angle is 32, now I've got this other triangle here. So now I've got this triangle. Don't forget, triangles add to 180. Anytime you've got a triangle, you can probably use that if you're talking about the angles. So 90 plus 32 is equal to 122. Subtract that from 180, and you get that this other angle here is 58. So from there, we can do the same. If we plug in x is 16, then we have up here this 32 plus 5 is 37. So if we take 90 and subtract 37, then we find out that this angle is 53. You would find out the same thing here. This angle is also 53, and this angle is 58. So they're not bisected, but we know that they're congruent. So that gave us all of the pieces that we were looking for. So in two, we're talking all about the sides. So when we're talking about the sides again, we do need to remember that these are right triangles. That's going to be important because I'm asking for other missing side lengths. So let's start with the one that we have the most of, and I have the most of these sides. And so we're going to use Pythagorean theorem. So I have y squared plus 72 squared is equal to 75 squared. So if you take 75 squared and you subtract 72 squared, you get 441. So y squared is equal to 441. Square root both sides, and you get that y is 21. So y is 21. If y is 21, then w is 21 because that one diagonal bisects the one that connects the non-vertex angles. So those are both 21. So now these two top pieces, also we know that these consecutive sides are congruent, so x is 75. And then we know r and s have to be the same size, so we need to do Pythagorean theorem again. So we have 20 squared plus 21 squared is equal to r squared. So 20 squared plus 21 squared. Add those together and take the square root of that, and we get that r is 29. So r is 29, which means that s is also 29. So one of the most important things that we're finding out so far about kites is remembering those right angles in the corners or in the middle, because we've used that both times. Those diagonals are perpendicular to each other. So let's look at this next example. So the non-congruent sides of a kite are in a ratio of 2 to 9. Now, we've done these types of problems before, like when I gave you the ratios of the angles of a triangle. We're in 1 to 2 to 3, we would say 1x plus 2x plus 3x equals 180. So we're going to do the same thing. What this means is that if we have our non-congruent sides are in a ratio of 2 to 9, then this side would be 2x and this side would be 9x because they have the same ratio, so they have the same multiplier. Now the perimeter of the kite, that's all the way around, is 154, which means I need all of the sides. So now I've got two 2x's and two 9x's. So 18 plus 4x is 22x is equal to 154. 154 divided by 22 is 7. So x is 7. Now it asks what's the length of each side. So we need to go back and we need to plug it in. So the length of each side, we would have 14, 14, 63, and 63. And you can see that they are a ratio of 2 to 9, right? If I do 14 over 63 and reduce that, I get a ratio of 2 to 9. So that's where that ratio of 2 to 9 comes from. So if we go back and look at our coordinate geometry, let's look at this one. P is at 2, 4. A is at 5, 1. R is at 2, negative 7. And K is at negative 1, 1. So the question is, determine the best name for the quadrilateral. So it does look like it's a kite, which makes sense since this is that type of, since we're studying that right now, right? Let's just double check and make sure. I can look real quick and see if I go up 3 over 1, 2, 3. So that's 3 and 3. Let's check this side. That's up 3 and over 3. What that means to me is if I were to finish out Pythagorean theorem, those two sides would be congruent. If I were to check 1, 2, 3, 4, 5, 6, let's see. So that's from 7 to 1. So that's 8 and 3. And this is 8 and 3. So since those would be the same with Pythagorean theorem, these two are congruent. So one way to test for a kite is you would test your non-consecutive sides. So you want to make sure that, or your consecutive sides, we want to make sure that two sides are congruent. That's one way to test. Here's the other way to test. I could have also checked. So one, you want to check your sides. Okay, and you only want two pair that are consecutive. Your consecutive sides are congruent, not your opposite sides. If your opposite sides are congruent, then you have to talk about a parallelogram, and potentially a trapezoid. So two, the other thing you could check is you could check your diagonals. Because the other thing that can make it a kite is we can double check our diagonals. We need our diagonals to be perpendicular to each other, and we can tell we've got a vertical line and a horizontal line, so those are perpendicular. So this is a kite. Okay, you would never check your angles unless you want to do trig. We don't have a way of measuring the angles in the corners, and so you wouldn't want to prove that K is congruent to A. You wouldn't want to prove that. You wouldn't want to prove that P is not congruent to R. So you don't want to use angles when you're trying to prove what shape they are, unless you want to prove that they are perpendicular. That's the only time you ever want to use angles, when you're trying to give the best name for a quadrilateral when you're doing coordinate geometry. Let's look at this one. -4, -1 is W. X is at 0, -4. Y is at 4, -1. And Z is at 0, 2. So we have this shape here. We need to test and see what this is. Now, it kind of looks like it could be a kite. We need to double check. So I think the easiest way to start, and you can do different things, but let's look first. There's one diagonal and there's the other diagonal. Now, here's what I notice is that this diagonal is 4 and 4, this diagonal is 3 and 3. So those diagonals, both of those have been bisected, not just one of them, but both of them. So this is not a kite. It's definitely a parallelogram. The question is, what kind of parallelogram? And so we just keep working our way through. So at least it's some kind of parallelogram, and let's see if it's some kind of special parallelogram. So one thing we could check is we could check the lengths of the sides to see if it's a rhombus or anything special. So let's look. So this side is up 3 and over 4. This side is up 3 and over 4. And so then this side is 3 and 4. And this side is 3 and 4. Those rises over runs come in very handy. So what I know is that each of these side lengths is 5. Normally I wouldn't have figured those out. I wouldn't have finished it because I know they're all the same. So I do know that all the side lengths are the same. So we know now that it is rhombus. So it is actually a rhombus, not a parallelogram. It's more specifically, that is the best name, right? We want the best name. Now, the other thing that we notice is not only are those diagonals bisected, but those diagonals are perpendicular. So that was another hint that this was a rhombus, because our diagonals are perpendicular. Now, the question is it a square? So we got to test if it's a square. To see if it's a square, we need our angles to be right angles. So I know the slope of WZ is rise 3, run 4, and I know the slope of ZY is rise 3, run back 4. Well, those are not opposite reciprocal slopes, so it's not a square. So the best we can be is a rhombus. So the best name for this quadrilateral is a rhombus. So you just kind of have to go through and start to use those properties to figure out what's the best one, but you do always want to check more and more specifically to see which one it definitely is. So a kite, remember the properties of your kites. You've got your no parallel sides. Your consecutive sides are congruent, but not your opposite sides. Your diagonals are perpendicular. Your vertex angles are bisected, but your non-vertex angles are not. Your non-vertex angles are congruent, but your vertex angles are not. And then the diagonal connecting the vertex angles bisects the other diagonal. So those are the qualities that you need to know to be able to set up and solve problems for a kite.